Good morning. Happy New Year, everybody. Glad to see you all are here and interested and willing to continue. I hope everyone had a happy holiday and a very happy New Year. We're glad to be back at doing our presentation. I'm going to give it just one more minute to let any late joiners join in, and then we'll jump right in. We've got a lot to cover today, so we'll give it just a minute here. All right. Well, I think we can go ahead and get started. So, Valeria, did you restart the recording? Yes, it looks like you did. Okay, thank you. I'm glad you remembered to do that. I always forget. Oh, those are supposed to be off. Notifications are supposed to be off. Give me just 1 second to manage that, guys. I apologize. All right, hopefully that'll take care of it. Okay, so sorry for that distraction. So welcome everybody, all of our participants in CNMI and Guam and American Samoa and a few other places. Glad to have you today, whether it's tomorrow morning or this afternoon or wherever you might be. I'm glad you could be here. So today we are at the midpoint of our operator training series. So this is session 14. It's hard to believe, but we've been doing this for quite some time now. So we're going to spend today just kind of reviewing where we've been, and then taking a look at where we're headed for the rest of the series. And want to make sure that if you, as we're going through this review, if any of it feels foggy or you didn't get to attend that session, that you understand that every single one of these sessions is recorded. All of the content is shared. So we'll make sure that you can go and review it, because we know that you are here because more than likely you are planning to take one of the wastewater operator certification tests. And so all of the content that we've shared so far is relevant to taking that test, and we want to make sure that it all feels familiar and comfortable. And if not, you know where to go to refresh. So today will be kind of high level review. So keep in mind that we're really not trying to get in depth. We're trying to make sure that you remember all that we've covered, you catch up on any of the sessions that you might have missed. You know how to access that material. And then if you've got questions, we're happy to try and answer those. But today really is about review. So high level review. So please feel free to use the chat feature if you've got questions. And we will do our best to answer them. But because it is a review session, we're covering a lot of content. So we will try to keep things moving along today. So thanks again for being here. My name is Dawn Nall, and I am a research engineer, project director at the Southwest EOC, and I'm joined with my coworker Valeria, and she's helping to monitor questions and keep things moving. If you have any audio questions or anything's not working, please let us know so we can help you, get to where you can hear us, and we can get things fixed for on your side or our side or whatever we need to do. So Valeria will be helping monitor all of those things and keeping things running in the back, so I can focus on the content. So we are with the Southwest Environmental Finance Center, which is a part of UNM's School of Engineering, the University of New Mexico, the School of Engineering. And this training series is funded by the Environmental Protection Agency, EPA. We want to make sure that you remember that if you're attending in a group, that you sign in on the sign-in sheet so that you get credit for attending, and you get your hours for attending this training. So the training program, we're going to be reviewing, like I said today, but the training program itself is designed to supplement and to reinforce the ABC Need to Know criteria for the wastewater operator level 1 and 2 exams. We will cover some higher level topics. We won't always follow the exact order listed in the need to knows, but we are covering content that should be very relevant to the operator certification exam, and the types of questions that they're asking in the material that you need to know. So get familiar with the ABC operator certification website if you haven't already. so that you can kind of follow along as well. Also, I mentioned that everything that we do is posted on our website. So at the top of this screen is our web address, our Southwest CFC website address. So swefc.unm.edu. And on our homepage or from our homepage, you can get to the OpCerts training, or if you type this web address in directly, you can get there. And this is what the page looks like. And it's got the schedule and then links to everything that's been posted, or you can jump straight to the wastewater trainings or straight to the drinking water trainings. And if you scroll down on this page, you will be able to see past the schedule. You will be able to see a list of all of the recordings on YouTube. So you can view them on our website or you can view them on YouTube. So this page should be very familiar to you. And if it's not, please become familiar with it, because everything that we do, all of the handouts that we mentioned, all of the links in the presentations can be accessed from these downloadable PowerPoints. You can rewatch the webinar recordings if you need to. If there's a certain part that you felt like maybe you wanted to review, you can jump straight to it. So those are all helpful tools for you. So make sure that you have access to this website, you're familiar with this website, and that you can get to it at any time, day or night. And those recordings are there for you, and the PowerPoint slides as well. So upcoming 2026 is here. Today is our first session, and it is the review session. And then we will be moving into a bit more detailed topics than the first half, but we'll be looking at disinfection. We'll go into deeper wastewater math, some of the more wastewater specific math. We've done some higher level math courses already. Solids handling, sampling, regulations, treatment system maintenance, lab procedures, using technology, and then a final course review session all the way in July. So the trainers will vary depending on the topic. If you've been with us in the previous sessions, I've done a couple, AJ, James, Shannon. We've had several people present trainings. So all of us are a part of the Southwest CFC and are happy to be a part of this training series. So today, what we really want to accomplish is the review of each of the sessions that we've held so far. So we've got study tips, treatment overview, wastewater math, collection systems, operator safety, preliminary treatment, primary treatment, and activated sludge. So we're going to cover every one of those in a short amount of time. We've covered them in depth in individual sessions. So here we go. Hold on. gonna cover a lot. So our very first session way back in June of 2025 was on studying tips. It was an introductory session, and then we covered some study tips. And you can see here, I do have the YouTube link. So as soon as we post these presentations, the PowerPoint slides, you'll be able to click right there. But also, if you go straight to the Southwest CFC's website, you'll be able to click right on session 1. In whatever way works best for you. So when we discuss studying tips, we covered several things, and I want to highlight a few of those, help you remember, make sure you're familiar, make sure you're comfortable with the content. So for study tips, some of the things that we mentioned, we said, make sure that you start early and that you manage your time well. So don't start studying for the test the week before, right? It takes a bit more effort than that, and a bit more planning than that, and a bit more time management. Make a study plan and focus on your weakest areas. Use the practice tests that are available, flashcards, a partner. Leverage your on-the-job experience and ask questions when you're out in the field about what might be on the test, things that you need to learn about that you don't already know. Read those training manuals and the need-to-know guides that ABC does offer. When you're preparing for the test, things that you should be aware of. The exams have 100 questions for the level 1 and level 2, and they do include math. You want to be able to understand the question formats. You will have questions that want you to recall things. They'll have questions where you apply your knowledge, and they'll have questions where you're analyzing information. You want to learn your formulas and your conversion tables. So ABC does provide some formulas and conversions. So you want to get familiar with that. You want to understand what they mean. You want to know how to use them. Monitor your time during the test. You should skip questions that are tough and return to them if you have time to. But make sure that you answer all of the questions you know before you spend time on questions that you're not certain about. When you're looking at your test questions, you want to use elimination and common sense for your multiple choice questions. If you can eliminate B, it doesn't make any sense at all, then eliminate B, and now you have a 1 in 3 chance instead of a 1 in 4 chance of getting it right. There are study guides available in a lot of different formats. The one on the left is from Sac State. It's a $90 guidebook, but we've also provided those to you guys for free for you to use. They're available at your utilities. The one on the right is from WEF, and there are other, each of these has different volumes and different information. There are study guides on state websites that can be useful. We've got a list of some of them here. There are, different states have different resources that can be free and can be really useful as well. So now we're going to move into session 2. Session 2 was an overview and a big picture overview of what wastewater treatment is. And this session was held back in July. And again, the YouTube link is here. So you can click on it directly when you download these slides, or you can access it from our website. So when we talked about treatment, we covered several high-level topics, but the first thing that we talked about is, why do we treat wastewater? So, of course, we treat wastewater to remove pollution and contaminants that are known to cause damage to the receiving bodies of water and disrupt the ability of other communities to treat their drinking water. Improperly treated wastewater can cause human sickness in waters that are used for fishing, for recreation, and of course as drinking water sources. Improperly treated wastewater that's discharged to the environment can kill local wildlife. It can cause long-term issues. It's also federally regulated. Any wastewater treatment plant that discharges to a point source, such as a river or a lake, is required to have an NPDES permit, which sets loading limits on different contaminants in the wastewater that the wastewater treatment plants have to treat for. So what do we treat the wastewater for? Well, we treat for excess nutrients. Algae thrive in high nutrient environments, and they'll outcompete other plants and wildlife in the affected area. They'll grow out of control. They use up the oxygen. They can create dead zones or septic conditions in bodies of water. So we're definitely treating for nutrient removal. Pathogens in wastewater cause human diseases. Some important ones to know that frequently appear in certification exams are your cholera, typhoid, hepatitis, dysentery, polio. All of those can be carried in water. Solids and debris add to current amounts of litter that are polluting the environment, especially plastics that are slowly breaking down. And then there's the ongoing concern of the effects of what we're now dealing with microplastics. Heavy metals can disrupt development in wildlife and humans. The same with pharmaceuticals. Lots of emerging contaminants that EPA is looking at right now. But all of those are things that we treat for. So, of course, as you're learning more and more about wastewater, understanding what it is that wastewater treatment is about is super important. What is this NPDES permit that we're talking about? National Pollutant Discharge Elimination System. So if you discharge to a body of water that's considered a body of in the U.S., you have to have an NPDES permit. So it's required for facilities discharging to surface water. I guess that's not necessarily the case for tribal members, but it can be, especially depending on the body of water that you're discharging to. So understanding and being familiar with what these permits are for is important, because they do specify your effluent limits of what can be in the water whenever you're discharging. It, of course, regulates your sewer overflows, stormwater, national pre-treatment programs, biosolids. It sets your effluent limits. It regulates pre-treatment. And if you are not able to meet your permit, you've had, treatments not working correctly, or you've had an issue or a failure, enforcement can include a notice of violation, administrative orders, fines, and even criminal prosecution. Because the work that you guys do is very important to public safety and health. So if it's negligent intentionally, it could even lead to prosecution. So very important to know and understand. The general treatment process that we talked about in this webinar, kind of 6 different levels. The collection system moves the wastewater from the home to the plant. Preliminary treatment is your large solids removal, your screening, your drip removal. Primary treatment removes your organic matter. Then we get into secondary treatment, where we're further removing organics. The tertiary treatment, not all systems have tertiary treatment, but it is something you should be aware of and understand. This is a polishing stage, and typically it consists of disinfection, but it could also incorporate specialized contaminant removal, such as metals removal or phosphorus removal. And then sludge handling is the process, of course, where your solids are removed and treated and disposed of in a safe and healthy way. So this is kind of a visualization of that overall treatment process. What is wastewater treatment? So you can kind of see here we have the wastewater influent at the beginning, and then the wastewater effluent at the end. And in between there, we have our primary treatment, our secondary treatment, our tertiary treatment, our solids handling, and treatment. So all of those are things that we will talk about over the course of the series for you to be familiar with. The next 2 sessions, we talked about wastewater math. And we will have 2 more sessions on wastewater math. We understand that the math portion of the wastewater operator certification exam can be some of the most challenging sections. And so we want to make sure that you've got all of the information that you need. And if you feel like the math is an area that you aren't the strongest at, make sure that you go back and review these other sessions and get as comfortable as you can with the content that we share here. So 2 different sessions, one at the end of July, one at the beginning of August. And some of the concepts that we covered in these sessions, we said these are the things that you need to make sure that you understand. These are some of the beginning math concepts to understand. So equations, percentages, units, and conversions. So if any of that sounds like I'm not speaking your language, then let's take some time to go back and review and get familiar with these concepts. So one of the first things that we wanted to talk to you about was the order of operations. When you are looking at an equation, and it has different things in there, you want to know that there is an order that you are supposed to go about doing that math, and it is not necessarily left to right. Okay, so there's a phrase, please excuse my dear Aunt Sally, PEMDAS, that should help you remember what these concepts are and the order that they go in. So when you're looking at a formula, you've got parentheses. Anything inside the parentheses you do first. Then any exponents. The exponents are the little numbers that are high up that could be meaning you square it or it's cubed to the second or to the third. So parentheses, then exponents, then you multiply or divide, then you add or subtract. So order of operations, super important to know, be familiar with, understand. And if you have not heard of this before, it's something that we want to make sure that you do become very familiar with, because there will be times when the math isn't going to go left to right, and you do need to understand the order of operations. And then algebra. So algebra is essentially solving for the unknown and rearranging things. So if you have an unknown, which is a letter such as D, a T, or an X, in your equation, that's what you are looking to solve for, right? That's the answer you're trying to get to. So that means that you need to get it on one side of the equal sign all by itself and everything else on the other side. And you do that by doing the opposite sign. So here, 46 plus x equals 98. So you want to get x by itself. So that means you have to get rid of this 46. So we're going to subtract 46 from this side and subtract 46 from this side, and that will tell us what x is. Okay, so understanding how to rearrange equations to solve for the unknown. That's the first step in algebra. And you will be doing a lot of that in wastewater treatment, especially when you're looking at some of the math questions on the test. So understanding how to rearrange equations and what that variable stands for is important. Understanding fractions and decimals, something else that we spent a fair amount of time talking about. So fractions and decimals, that means we're using a fraction or a decimal to represent part of a whole, right? So a fraction is a piece of the pie. If you have half of the pie, that 1/2 is a fraction, or 2/3 of the pie, or any of those kinds of examples, those are fractions. Fractions and decimals can mean the same thing. They both mean part of a whole. So when you convert fractions to decimals, you want to divide the numerator, the top number, by the denominator, the bottom number. So 1/2, 1 divided by 2 is equal to 0.5. So that takes your fraction to a decimal, right? And then the other way around, decimals to fractions, you want to write that decimal as a fraction. So you're going to multiply the numerator and the denominator both by 100. And then you want to simplify to the lowest common denominator. So if you multiply 2.75 by 100, you get 275. And of course, 1 would be the bottom. 2.75 divided by 1 is still 2.75. Multiply it by 100, that's 100. So 275 1/100ths is your fraction, but you can simplify that down to 11/4. So those are concepts that you should be familiar with. And then percentages, that's just another fraction. So percent is parts of 100, right? So fractions with a 100 in the denominator, the bottom. So it can be converted to a fraction or to a decimal. 30% is equal to 30 1/100ths, which is also equal to 0.3 or 3/10. Okay, so those are concepts that we want you to be familiar with and be comfortable with going into the exam. The next thing we want you to be super familiar with and understand is units. Units will be on the test. They will ask you something in inches, or tell you something in inches and ask you for an answer in feet. Or, area could be square inches and then square feet. So making sure that you understand the units, what they are, and if you need to convert them to something else. And when we look at units, one of the things to keep in mind is that when we look at rates, rate is a variable or a measurement, and it's added to one of the other units. So what unit is in rate? So if we're looking at this rate, GPM, what does that stand for? Gallons per minute. That's time, right? So time is part of our unit when we're talking about rates. So make sure that you're looking, is it feet per second? Is it gallons per minute? What rate are they asking for? Okay. And as I mentioned earlier, the ABC formula sheet has a lot of unit conversion factors on it. So you can see here in the middle, your conversion factors. Make sure you're really familiar with this sheet before you go into your exam. How do we use conversion factors? Well, you're really multiplying or dividing your measurement by the conversion factor. You're just turning that conversion factor into a fraction and essentially multiplying by 1. Because you can multiply anything by 1 and not change its quantity, you're only changing the units. So you can go from gallons to liters. You can go from feet to inches. Lots of things you can convert to. Other things we wanted you to be familiar with: surface area basics. So when you're talking about surface area, you're talking about two-dimensional spaces. You're talking about something that's a square or a triangle or a rectangle. And so those are going to be units like inches squared, feet squared, miles squared, meters squared, acres. And you can convert from any one of those to another one with just that simple conversion factor. Okay. And then we go into, where would this be helpful? Surface area. Why would we care about surface area calculations? Well, you might be looking at something like a wastewater pond liner, or how much weed fabric you need, or how much paint you need, or how much building material you need. All of those would be surface area calculations. Then you can go even deeper, dive deep into some 3D water math. Now we're talking about volume. So this is where we have a length, a width, and a height. So this is a tank, this is a box, this is a cube, this is a cylinder. And so here you're going to have cubic units because you have length times width times height. So cubic feet, cubic meters. So you can see that you can multiply the length times the width times the height and get a volume, but we don't usually talk about volume in cubic feet. We talk about volume in gallons, so we can convert that cubic feet to gallons. And to do that, we use that conversion factor, and we can cancel out the units that are on the top and the bottom opposite one another. So we can get from 4,500 cubic feet to 33,660 gallons. So those are all things to be familiar with. When we talk about volume of a cylinder, it's a little bit different than the volume of a cube. So it's not length times width times height because it's round. So we don't have necessarily a length and a width. We have a circle. So we have to understand how that circle comes into effect. So the area of a circle times the height is how we get the volume of a cylinder. So you can either do that with diameter or with radius. Radius, of course, is the distance from the middle to the edge of the circle, and diameter is all the way across from one side of the circle to the other. The math, comes out the same. You're just looking at it from either you're comfortable using the radius or you're comfortable using the diameter. Radius is always, or diameter is always 2 times the radius. So things, again, to be familiar with. Another concept to be familiar with, water pressure. So here we're talking about feet of head or pounds per square inch. Those are the most common. And when we talk about water pressure, we talk about it in tanks a lot, right? So we have tank A here. It's 5 feet in diameter and 75 feet tall, and it holds 11,000 gallons of water. Tank B is 50 feet in diameter and 75 feet tall, and it holds 1.1 million gallons of water. If we have a pressure gauge down here at the bottom of each tank, which tank would have the highest pressure? Tank A or tank B? They have the same pressure because pressure has everything to do with how tall the tank is and not how much water is in the tank. So pressure is based on the feet of head. The volume's not important at all. It's the height of the water. And that's the direct relationship between feet of head and pressure. So 1 foot of water is 0.433 pounds per square inch of water, or 1 pound per square inch of water is 2.31 feet of water. Okay, so keep that in mind, that it doesn't matter how big the tank is, it matters how tall the tank is. The volume is irrelevant when we're talking about pressure. The next concept that we talked about, the next session, was on collection systems. We had 3 different sessions on collection systems. We started by talking about the gravity systems, the collection system, the gravity system. So if you think about a community, right, you've got a bunch of buildings and maybe they're laid out nice and square like this, maybe they're not. But you've got all these buildings and they have lines that go from the building out of the building. So the wastewater leaves the building through that service line or sewer connection line. And then those collection lines connect to a lateral or a branch sewer. From there, they connect to those slightly larger lines connect to the main sewer lines. Those bigger main sewer lines will connect to a trunk sewer line where you will more than likely have a lift station that goes to your wastewater treatment plant. And sometimes that big line to the wastewater treatment plant is your interceptor. You might also have a situation like this where you have a community that's at a lower elevation. So you have the connection lines, you have some laterals, and then you have a lift station, and then you have force main. So understanding what those components are, what purpose they serve, that's all important in part of your collection system knowledge. When we're looking at gravity collection systems, we want to be familiar with some of the design principles. So if water is moving through those pipes because of gravity, we know that we want the water to move fast enough that it prevents buildup in the pipe. So that's called scouring velocity. So we know that water needs to be moving at a minimum velocity of 2 feet per second. And so the slope of the pipe is important to understand, and the velocity of the water moving through the pipe is important to understand. When we look at collection systems, they're typically designed for a maximum expected flow, the peak flow, when the maximum population density has been developed. So if you're putting in a new neighborhood and you know that right now there's going to be 10 houses, but eventually there's going to be 50 houses, you don't want to put in sewer pipe that's too small for the 50 houses. You want to put in sewer pipe that will eventually serve all 50 homes. Also, we know that gravity sewer we don't want that pipe to be flowing full, because then there's no room for peak flow. There's no room for any, sudden unexpected flows. So the sewer lines should flow about half full during average flow times. Also, this allows for air to be in the pipe to allow for aerobic conditions to maintain. And then when we're looking at designing our wastewater treatment plants, we usually look at peaking factors between 2.5 to 3.5 times what the total average daily flow is. Also, if you're putting sewer line close to drinking water line, you don't want your sewer line to be above your drinking water line in case it leaks, right? So you always want it to be 2 feet or more below your water line. And if it's horizontal, if they're laying side by side, you want 4 feet between those two pipes, minimum. So those are some things that your design engineers have to be familiar with and understand, but also that you should be familiar with and understand, because if you're laying sewer line or you're working on sewer line, you want to understand why maintaining slope is important. Separation between water and sewer, pipe sizing is important so that you're not putting in pipe that's too small, and possibly leading to pipe clogging, or having velocities that are too high, different things that can happen if the pipe's not properly sized. We then talked about the different types of pipe. And so, we walked through the different types, and I'm sure you guys are familiar with some of these, but maybe not all of them. So if you see one of these on an exam, you now are familiar with it. You maybe not heard of VC pipe before. Now you are, vitrified clay. I think a lot of us are familiar with PVC and maybe, cast iron or ductile iron, maybe not. Asbestos cement, maybe not, depending on the age of your system and all of the different things that you've experienced in life. So just be familiar with the different types of pipe, and then the different types of pipe joints. So there are different types of joints, and not every type of joint works with every type of pipe. So understanding the different types of joints and when you can use them is something else to be a bit familiar with. And I don't think this is necessarily a straight up memorization, but just a familiarity, that if you're using PVC, you're going to be using a certain type of joint. So we want to make sure that those bits of knowledge are familiar to you. And then installation, so gravity collection systems. If you're thinking about your gravity pipe, of course, when you're thinking about installation, excavation safety is super important, something that you should be familiar with before you're ever in the field working on a sewer line. So your OSHA trench rules, understanding when you need to, we'll talk about it a bit more, but when to shore or have trench protection, those kinds of things. Also understanding how bedding and backfill impact your pipe integrity. If your pipe's not bedded correctly, if it's not got the right type of material around it, your pipe can compress, so it's no longer round, but it's more oval. So that pipe integrity becomes a problem. So understanding bedding and backfill is important. Knowing that your connections, the bells, if you have a bell type connection where one pipe slides over the other pipe for a small length, that the bells face upstream. Also understanding deflection testing and making sure that your pipe does stay round and that the water can continue to flow well. And then for service connections, the different types of service connections that there are out there, service T or saddle tees, insertion Ys, and that your connections are places where you can have infiltration and you can have root intrusion. You want to be really careful when you're doing service connections to prevent those from happening. And then finally, manholes in the collection system. Manholes are installed for maintenance access, and they're typically spaced 300 to 500 feet apart. And manholes are considered a confined space. And if you're entering a manhole, you have to make sure that you understand the safety requirements. Entering a manhole can be quite dangerous as sewer gases can build up in them. And lots of bad things can occur, suffocation and air poisoning and other things. So understanding your confined space safety before opening or entering a manhole, very important. The next thing we talked about with collection systems was pumping and force mains. And I did this presentation. So, so the pumping and force mains of collection systems, we talked about what's the purpose of a lift station. Well, the purpose is to raise wastewater from a lower elevation to a higher elevation. And of course, that would require a pump to move the water into the force main. And after the force main, gravity typically takes back over again. We don't pump from the lift station all the way to the wastewater treatment plant unless it's the lift station right at the treatment plant. And there are typically two different types of lift stations: a wet well, where there's only one chamber and the pumps are in the water, or a dry well where there are two chambers and the pumps are not in the water. They're adjacent to the chamber that holds the water. We walked through the lift station components. There are lots of parts: pumps, hardware, bar racks, valves, electrical systems, alarms, motor control centers, pump controls, force mains. So we walked through what they were. You need to know what these do and how they work and what's required. So for example, if a lift station hardware has to be high grade aluminum or stainless steel to prevent corrosion. So, where would you need that to be aluminum or stainless steel as opposed to a metal that could rust and fail? So understanding the components and how they work and what the requirements are for them is important. Most lift stations do have three-phase electrical service and backup generators. And that's not always the case, especially in our smaller systems. But I think for the operator certification exam, that's going to be the assumption, is that they have three-phase electrical and backup generators. So being familiar with those components is important. When we talked about lift stations, we talked about operating them. How do they operate? Well, the water flows into that wet well, into that like storage tank, that concrete storage tank. And as the water flows in, the water level goes up and up and up until it reaches the first set point. And at that first set point, the first pump should turn on and the water level should start to decrease because the pump is pumping water out of that tank. If, however, the water level continues to increase, a second set point will be reached and a second pump will come on. And this is only if the tank or the pump station is equipped with a lead lag pump. So sometimes they're not, but sometimes you have lead lag pumps where there is a second set point because flow rates can vary. So you could have a second set point. The water is then being pumped out faster than it enters, so the level decreases, a low level set point is reached, and that turns your pumps off. And those set points can be controlled by a variety of things, floats, gauges, different things. So understanding how they operate and what those set point controls are is important. And then maintaining lift stations, grit is always an issue, grease and scum and what it can do to a lift station, and especially those set points, clogging them, blocking them. And then odor control, you can have a fair amount of odor at lift stations because you are, creating some turbulence and releasing some wastewater gases. So there are ways to control the odor at lift stations. So all things to be familiar with. Lift stations have pumps in them. There's typically two types of pumps, positive displacement or centrifugal pumps. And so understanding the difference between those types of pumps is important. Lift station pumps are more often than not centrifugal pumps, but they could, obviously we talked about the two different types. They can be positive displacement, but more common centrifugal pumps. So understanding the operation of them, of course, you don't want to start them or run them dry because the water is used as lubrication. So if you run them dry, they're going to probably bind up, and that's never a good thing. And pumps can cavitate. If the pump's not running at the designed flow or pressure, it can create a vacuum. And that vacuum will cause the water to turn into a vapor. And when it returns to liquid, it reacts quickly. It causes damage to the pump, and over time, that can lead to significant damage. So understanding that a cavitating pump can sound like a can of marbles being shaken is important. There are other indications of cavitation as well, but the marble sound is a very common one. And then finally, lift stations, they pump the water out through a force main. So this is the discharge pipe of the lift station. It is under pressure. The water is under pressure. The rest of your system is probably not under pressure. It's gravity pipe. But here, your force mains, the water is under pressure. And you can trap air in the system and have shock waves or water hammer. It can decrease flow rates. It can increase pressure, and that can all increase your energy use. So air relief valves are sometimes installed to help allow that air to escape automatically. So again, high level, what we're covering about your pumps, your lift stations. Next, we talked about collection system maintenance. So some of the common collection system issues, we kind of categorize our most common collection system issues into these four areas: obstruction, structural issues, environmental issues, infiltration, and inflow. So being familiar with what can cause collection system obstructions is important. So how do you inspect or monitor your collection system? Well, there's several different ways. There are visual inspections, so popping your manhole lids, looking to see what's going on in the manhole. CCTV, so this is a video camera that you can put inside of your pipes and see the inside of your sewer system. Flow monitoring, where you look at measuring your flow rates to identify different flow patterns. Smoke testing, so you put smoke into the sewers, and if smoke is coming out in places it shouldn't be, that indicates connections, illegal connections, leaks. Other things, dye testing. This is where you put a dye into the water and you can trace your flow. And then there's acoustic sensors and sonar inspections that can help detect blockages, things of that nature. So how do we maintain our system? Well, we want to understand preventative versus emergency maintenance. Preventative is when it's scheduled work, it's proactive work, and emergency, of course, is unplanned, it's reactive. We want to aim for more preventative maintenance than emergency maintenance. Cleaning methods, we can use hydraulic jetting, mechanical rodding, chemical treatments, and then, of course, repairs where we have open cut excavation, or we use a trenchless method like pipe lining, pipe bursting, slip lining, and then there can be manhole rehabilitation as well. We talked about maintenance planning and scheduling. We want to use maintenance planning to organize and plan our routine preventative corrective maintenance. And then our emergency maintenance, harder to plan, but to be aware that we will still have emergency maintenance. Prioritizing our highest risk areas to prevent blockages. We also want to take into consideration the condition, the age, the material, and any historical data that we have. And we want to schedule maintenance using a calendar or condition-based scheduling. So those were all concepts we talked about in that session. Next, we talked about operator safety. So here, the different types of safety hazards: chemical hazards, physical hazards, biological hazards, environmental hazards, and other hazards. So all things that you need to be familiar with and be prepared to understand. You should have a safety program. The operator should be responsible for following it and using PPE and reporting your hazards, while the management should be responsible for designing the safety program, appointing officers, setting goals, and evaluating the results. So here you're identifying the causes of accidents, providing safety training, implementing an accident reporting system, and holding your supervisors responsible for implementing the safety program. When we think about actions that we can take to control workplace hazards, of course, the best thing to do is to eliminate them. And then work your way down this list to making sure that if we can't avoid them, that we're protecting the worker with our personal protective equipment, our PPE. When we think about hazard control, wastewater is considered, it can be an infectious material, so you want to use your PPE like your gloves, your safety glasses. Of course, it's water, so it can be slippery. You should use caution around any wet environment. You should learn to swim. And you should be familiar with where your personal flotation devices are. Electrical hazards exist with anything at the wastewater treatment plant or any lift station. You should have a lockout tagout program. Excavation safety. If you are digging, you should have excavation safety training using shoring, shielding, or sloping to prevent trench cave-in. It's almost impossible to save a life if there's a trench cave-in. Ladders are required in excavation safety. Chemical hazards, understanding what safety data sheets are, understanding the safety squares, those diamonds that have the different colors, and using your PPE. And then confined space, understanding that any confined space requires a permit and requires monitoring. Safety equipment, your respirators, your SCBA, your self-contained breathing apparatus, your emergency gear. And then I kind of added your gloves, your eye protection, your toe protection, and your inoculations. The next session that we looked at was preliminary treatment. So we started getting into the treatment process in this session back in October. So here we were looking at anything where the wastewater system influent is received at the treatment plant, the headworks. So these are your trunk lines, your interceptors. This is probably where you're doing flow measurement, where you have any pre-treatment, where you would do influent sampling. You may have odor control. You may have flow equalization. And flow equalization can also be used for emergency storage, which sometimes is necessary, and any pre-aeration. Flow measurement happens here. So flow is measured through a variety of different tools. So you might have magnetic flow meters or mag meters, a partial flume, V-notch weirs, rotometers, ultrasonic level sensors. You want to make sure that your flow meters are placed in easily accessible areas and that they're in long straight sections of pipe. If not, if they're in a place where there's turbulence, or it can create inaccurate readings. So different types of flow measurement that you should be familiar with. And then pre-treatment screening, the different types of bar screens include a bar screen itself, a manual bar screen, or a bar rack. And then cleaning them, you can have a manual raking or mechanical or automatic systems. The hazards that come with pre-treatment: slips, toxic gases, electrical risk, and physical strain. And then disposal of the screenings. The screenings are considered hazardous. They're typically landfilled or incinerated. Grit removal. You could have grit channels, you can have aerated grit chambers, you can have cyclone separators. They should be allowed to settle. So the ideal settling velocity, 1 foot per second. And again, disposal at a landfill. So other pretreatment information, we want you to be familiar with influent sampling, that you can do composite or grab samples. You may need odor control and your flow equalization pre-aeration. If you have equalization tanks, these are used to help manage your peak flows so you don't have this big, huge amount of water come in suddenly. It slows that flow down and makes the flow entering your wastewater treatment plant nearly the same all the time. And then pre-aeration can help improve your treatment efficiency, and it can help with reducing odors. The next session was on sedimentation, flocculation, and flotation. And goodness, I am moving through this as quick as I can, but we covered a lot of material. So if this is all sounding familiar to you, that's great news. And if not, I hope that you will take the time to go back and review some of these sessions. So the differences between sedimentation, flocculation, and flotation, they're similar, serve similar purposes. But sedimentation is where the heavy particles settle to the bottom by gravity. Flocculation is where we use something to cause the small particles to clump into larger ones, whether that's a polymer or a different type of chemical, which it makes your settling faster. Flotation is the opposite, where the lighter materials float to the surface, your fats, oils, and grease. And this is achieved with aeration, with chemicals, with heat, other ways. The sedimentation principle of solid settling and lighter items floating to the top is used throughout treatment. It can be in preliminary treatment, in grit removal. It can be in primary treatment, in removing your suspended solids in your clarifiers, and secondary treatment in your biological floc removal, if that's in your activated sludge process. So the idea of sedimentation is used all throughout wastewater treatment. So we need to be familiar with the design criteria for sedimentation. If we're looking at primary settling tanks or horizontal grit channels, you can see detention time is significantly different from one to the other. And understanding what that means, these are important factors for designing these types of treatment processes, but also for you to understand if you have a settling tank, is that water in there long enough to actually let things settle out? So you can use calculations to understand what's going on. So different operational calculations you should be familiar with. Settling time. This is the depth divided by the settling rate. The removal efficiency. The weir loading rate. So weir loading rate is flow over length, whereas surface loading rate is flow over surface area. And you can use these calculations to compare facilities to common design values. And when you use them in combination with your lab tests, your process control tests, these formulas can help you to verify your operational goals are being achieved. And if the lab tests are showing poor performance, these math tests can help identify where the problem's occurring. So it's more than just being familiar with the equation so that you can answer a question on a test. It really is about understanding the operations of your system and if they're operating the way that you think they should be operating. Then we talked about fixed film processes. We're now in November. We're hitting the end here, guys. So fixed film processes, when we talk about fixed film, we're talking about microorganisms that treat the waste living in some type of a film that's attached to or fixed to some type of a media in the treatment process. So fixed film, we typically talk about the primarily the removal of BOD. And here we have trickling filters and we have rotating biological contactors. In both cases, there's a media, and in both cases, there's a film and there's water. The difference is that with trickling filters, it's stationary media and the air is in the voids between the media. And with RBCs, the media rotates through the wastewater. So it's exposing the biofilm to the water and the air as it rotates. So for either one of these, the design and operational highlights, there are differences and similarities. So the trickling filter, as I said, the media is stationary, whereas with the RBCs that rotates. The media type, there's organic, which is typically rock, or synthetic, which is typically plastic. We don't see too many trickling filters being designed with rock anymore, but there are plenty that still exist around the country. And so the weight difference is important to understand. Whereas the media types with RBCs, there's standard density and then there's high density. And the differences here are if you are just looking for BOD removal or if you're also looking for nitrification. So a couple of things to understand about the design. These performance parameters, the math is the same whether we're looking at trickling filters or RBCs, but these equations are things that you should be familiar with. So organic loading rate, this is where we're looking at the amount of the organic matter, the BOD, that's coming into the system. And the hydraulic loading rate is the amount of water fed into the system per day in relation to the surface area. So organic floating rate is the amount, essentially the amount of food we're feeding it, and hydraulic is the amount of water we're feeding it. A couple of others, recirculation. So you probably have some of the water that's been treated going back to the beginning of the process. This allows you to control the volume of the water that's entering the system without impacting the amount of BOD. So you want to understand what that ratio is. And then your dosing rate, this is used to control the biofilm thickness. And this is by adjusting the speed. So these formulas are things that you should be familiar with, you should understand, you should practice some math. And we will get into more of that in the sessions that are coming up in the next year or the next few months. Things that you have to sample with this type of treatment with fixed film, TSS, BOD, COD, DO, pH, temperature, chlorine residual, and E. coli, or coliform. So things to be familiar with there. And then why might you want to use one or the other? RBCs are suitable for smaller facilities. Trickling filters have lower energy requirements, but they can generate odors. They can ice over in colder weather, which you guys don't have a lot to deal with that, but there can be issues, and since the test is taken nationally, things to be familiar with. Finally, our last two sessions before the holiday break, we're on activated sludge. And we are right at time. If you guys can stick with me for 5 more minutes, we'll get through this. And then we will be looking at new content in our next session in 2 weeks. So what is the activated sludge process? Well, first, it's a secondary process. Settling is considered primary treatment, and activated sludge follows it as a secondary process. It is a biological treatment. It uses living organisms to treat wastewater. The microorganisms convert the dissolved and suspended organics into those settleable solids. So we talked about the settling and how that works. This process mimics what we see in nature, and they use microorganisms that are already present in the water. The primary goal is to remove our BOD, but it can actually achieve more than that. Activated sludge can remove BOD, suspended solids, ammonia, nitrates, pathogens, and it can aid in other pollutant removal as well. So all things to understand and be familiar with. How does it work? Well, the influent comes into an aeration tank where air is being pumped in and mixed with the cultivated biomass called the mixed liquor, and it uses the oxygen. The microorganisms use that oxygen to allow them to break down the organics. The sludge, then the microorganism byproduct is the sludge. It settles in the secondary clarifier where it's either recycled or it's wasted. And so the components of activated sludge, you have your aeration systems. They might be diffuse, they might be mechanical, they might be jet aerators, and that blower typically. You have mixers to maintain the suspension and prevent dead zones. And then you have secondary clarifiers for settling. And of course, you have monitoring equipment for DO, MLSS, ammonia, nitrates. So our flow schematic, All of the primary treatment. So we talked about your plant influent, your pre-treatment, your primary treatment where you might have grit removal and flow measurement. Then you would have your aeration tank. So this is where we're pumping air into the tank and the water's flowing into it. The water goes to the secondary clarifier for the solids to settle out. And the solids are removed and recycled back into the aeration tank or wasted as solid waste. So the activated sludge process is this part in the gray box. And then, of course, we would have solids handling and influent recycling and biosolids. And so we'll talk about those more in upcoming sessions. And then disinfection of the treated water before it goes to the receiving waters. So activated sludge, understanding some of the biology and the nitrogen removal through the nitrification and denitrification. Those were things we covered. And then we talked about some of our operational variables, what our key parameters are. Being familiar with what these key parameters are is super important to having a successful activated sludge process. If you don't understand what DO is and what those levels should be, you can be feeding too much air and wasting energy or not enough air. So really understanding these parameters is important for successful activated sludge. And then what kind of lab tests do we do? So we had a little video. This is what healthy activated sludge should look like. You don't want a lot of foam, but you want to be able to see that air. If your process looks like this, you can have confidence that at the very least your biomass is consuming the organics in your flow. So why are the activated sludge processes, the activated sludge process characteristics and control important? I talked about understanding DO and the different things. The biological process has more variables than physical and chemical processes. So the operational data has to be used to adjust your process and to make sure that you're controlling that process based on the data that you're getting back. The characteristics can change daily, if not more frequently. And this process, the activated sludge process, must be maintained in a balanced state. So you want to maintain the aeration tank to produce floc-forming bacteria. You want to make sure that you're flocculating and settling the flocs inside the secondary clarifier, and you're managing the activated sludge to maintain a healthy proportion of microorganisms in the system. So you're going to do that with testing. So you're going to look at influent parameters, what's going on with the water coming in. So what's your flow rate, what's your TSS, what's your BOD, what's your ammonia, what's the temperature, so on and so forth. You can see the whole list here. And then what's going on in the process itself within the activated sludge process. So you're going to be looking at your DO levels, your F to M ratios, your MLSS, your solids retention time. So understanding these parameters helps you understand what's going on in the activated sludge process. So you can then make adjustments to keep that process healthy and working properly. Otherwise, you might have sludge that's not settling, or you might have buildup of sludge in your clarifier, or just a whole abundance of things that can go wrong. So we want to make sure you really understand the importance of testing your variables, understanding those variables, which help you then understand how to make adjustments to your process. So activated sludge is pretty straightforward, but because your wastewater can change regularly, making sure that you understand what those variables are and what you need to change to keep the process operating smoothly, super important. So we did talk about, those variables and how you can make adjustments and what the ranges are that you should be looking for in this presentation. So that's essentially all that we have talked about for the last 6 months in 1 hour and 6 minutes, I guess. So I hope that you found value in kind of reviewing where we've been. Hopefully we'll prepare you for where we're going. we are working our way through the treatment process. And so the content that we've covered so far, if any of it felt unfamiliar, if you need to review, all of that content's available to you. Also, you can reach out to us at any time. We're happy to help answer questions, to review content, anything in a presentation that maybe wasn't clear to you, or you'd like us to talk to you a bit more about. We are happy to do that. So please reach out to us. Let us know if you have questions, if there are things that you would like us to review in more detail. We do have the rest of the sessions planned out, but that doesn't mean that we can't change them. They're not written in stone. So if it seems like we need to cover something a bit more detailed, please let us know. We're doing this to help you guys prepare for the test. And so this is for you. So please make sure that we are meeting your needs. So reach out to us, let us know. I will open the chat to questions if you have any questions. I know that was kind of like drinking from a fire hose, but hopefully it helped to trigger some memories about the sessions and make you think about what you need to review and what you're comfortable with right now. So if there are any questions, now is your chance. And thank you so much for sticking with me for a few extra minutes. I do appreciate it. And a reminder to sign in so that you get credit for being here today. All right, well, I'm not seeing any questions come in right now, so thank you all for being here. We will wrap this up now, and we look forward to seeing you at our next session. Thank you all again. Take care.